let's briefly look now at how we get to neuron densities. We're going to come back to this much later in the next MOOCs, actually, about how do we reconstruct the circuit. But I just want to show you how that is used, how we use the molecular profiling to actually get to neuronal densities. So here's a movie that you can see that is showing stained cells. These are cell bodies. Actually, it's staining everything, glia and neurons. But then you can stain, you can apply different stains, many different stains. So you can stain for the glia, you can stain for GABAergic cells, and you can stain for neurons, just neurons in general. And you can do many other stains. And using these different stains, you can then start identifying how many neurons there are in each of the layers of the neocortex. And these are some numbers, and this is in the Cell paper that you should be following during this course. The important point to make here also is that counting how many cells there are in a particular brain region is very unreliable. It's the most unreliable, probably one of the most unreliable data sets you can get. So if you read a paper, it tells you how many cells there are in the brain or in a particular part of the brain, just bear in mind that there's 20 other papers that will be contradicting that data. The most reliable way to do this is to do block staining, a big block, and then you use clarity so that you make sure that all your neurons are in that piece of tissue. And there's a lot of care that has to be taken to make sure that you've controlled for shrinkage and many other things, to make sure that you really do know how many neurons there are in a particular part of the brain. Okay, so here's just a movie just showing you that you put them all together. We're going to come back to this much more in the future. And here again is you have the in silico staining of each of these different peptides. It's not important what they are. It's just that you have many different peptides, and each of the neuron is stained according to those maps that I showed you before. And then you can do so you stain your virtual tissue or the reconstruction, and then you can have a look at what real tissue looks like when it's stained with the same peptides. Okay, and then you count, and you look at the distributions that you see in silico and the distributions you see in the real system. So then what you find, if you actually, after you've reconstructed the circuit with different cells in different layers, then you find that it actually correlates in terms of the recipe, which was obtained from getting those densities. It's one different data set, and the actual measurements obtained from the real tissue. So the reconstruction then basically looks like the real tissue. So if you were an anatomist and you were staining tissue, and you stained the virtual piece of tissue, you would see the same patterns of staining as you do see in the actual in the brain tissue.